Alright, let's hit some more problems here. I want to point out again that we once again, we're not going to switch x and y because the values that we're plugging in don't switch. If I take mass in this case, right, in terms of length, switching m and l doesn't make mass magically turn into length, nor does it take length and make it magically turn into mass. So here we go. We're going to write the inverse of cubic models. And it might take me a little bit. I got a calculator that's not the best calculator sitting on my lap. And here we go. What'd you say, buddy? No clue. You want to say hi to anybody? The last one didn't say.
Hi. Show hi to people.
Show hi to people. Hello. Alright. So, similar to quadratics, cubic functions can be used to model many real-world applications. So let's do one. So we have a function here that says m given L, which we already know is mass and length, is equal to, oh my goodness, let's write that differently. M given L, right, is equal to, what's tens, hundreds, thousands, 10,000, 100,000, 100 thousandths of the liter cubed. Alright, or length cubed, and our length is in centimeters. Alright, so in this one our input is length in centimeters, our output is mass. Alright, we're going to keep going with this, see what happens. Alright, so let's go ahead and find our inverse. So I'm just going to use mass equals 1 over 100,000, right? Length cubed. We multiply both sides by 100,000. That gives me 100. This one I think is going to turn out pretty nice. Equals length cubed. That's times mass. And if we take our cubic root, we get our length is equal to, let's see. Wow, it's not bad. Our length is equal to the 10 times the mass. Alright, the cubic root of, what we got? 100,000 is 10, because 10 cubed gives me that many zeros, right? So 10 cubed gives me 1,000, and times 10, oh, let me see real quick. Oh, I'm so wrong. Yeah, I needed one more zero. So we're going to get 46.4 times the mass, right? Because 10 would give me a couple extra zeros. I need one more. Wow. All right. So the length is equal to 46.4 times the mass. So, and then what does it give us? It says, and it doesn't ask us to fill anything out yet. Alright, it says find the inverse, and that is it. So our inverse, so we'll say L given mass is equal to 46.4 times the mass. That's it. Nothing to plug in. So let's keep going. So here we go. We're given an area given the radius is what this is. That is a sphere, right? So the surface area of the sphere with a radius r is this. So I'm going to say the area equals 4/3 pi r cubed. And let's go ahead and solve. So we can start off by multiplying by 3/4 on both sides by 3/4. And I get 3/4 a is equal to pi r cubed. Divide by pi, divide this side by pi. And we get, let's bring it up here, our radius cubed is equal to 3a over 4 pi, which is probably the best way to write that, right? Pi is going to flip over and go on the bottom. Alright. And then we're going to take the cubed root of this, and that's going to be the cubed root of everything. So your radius is equal to the cubed root of 3a over 4 pi. And that's it. Alright. Let's do one more down here and we'll be done. So let's see. What is this? Mass and radius. Alright. So we got the the mass is equal to 44/3 pi r cubed. I'm going to show this one a little bit different so you can, it's probably a little confusing right here, so let me show this different. If we multiply by 3/44, let's keep it as a fraction over here. I got 3 times the mass over 44 is equal to pi r cubed. I want you to see this appearing on bottom this time. Divide both sides by, or multiply both sides by 1/pi, right? I got 3/m equals 44/pi equals r cubed. We're going to go ahead and take the cube root of all of that. And r is equal to the cube root of 3/44 and m right there and pi on the bottom. You can also do this, so I'm going to show you what else you can do. You can actually put all the numbers into it and give yourself a good estimation. That's exact. Let me pull this up on my calculator. I'll do the best I can with this on the calculator. So what you could do is say 3 divided by 4 pi. So here I go. 3 divided by 4 pi. I know there's pi on this thing. Oh, there it is, pi. And then you could take the cube root of that, which I'm going to do right now. And you could change this into approximately, some of you squiggling lines, 0.62. And then we could say times the cube root of m. So that's if you work all this out, right? 3 divided by 44 pi. Or you could say 3 divided by 44 divided by pi, right? And when you plug all that in to your calculator, you get about 0.62, and then you can keep the, in this case, m, your mass, the cube root of mass, separately. And there it is. So hopefully you'll be okay with this. And that's all the pages. See you soon.